So this activity is somewhat based on the truth, because obviously the circumstances are not exactly the same. But Fibonacci was a mathematician that he did study rabbits, and you're going to see more information, even more pictures in your learning notes about this. But for this activity, we are going to explore what Fibonacci intended to explore and what he came up with. It says a certain man put a pair of rabbits in a place surrounded on all sides by a wall so they cannot escape. Many pairs of rabbits can be produced from one pair in a year. And suppose that, and then these are the conditions, suppose that each pair begets a new pair, and then from the second month on, they become productive, right? So you want to, again, the rabbits take 1 month to grow up, so they cannot make babies as soon as they're born. They need to have a whole month. Then after a month, they can get pregnant, okay? So they can go ahead and have babies. And then it will take a whole month from maturity to be able to have born new babies. All rabbits never die. They all live in ideal conditions. It's always going to be two, one female and one male. And you want to know how many would there be, how many pairs of rabbits would there be in 12 months. So different strategies to use. You can use visual, like drawing the rabbits. And since this is in a year, we're going to start with all the months, like January, February, March, April, May. And then we're going to be writing the number of pairs of rabbits. So pairs is male, female together. So this is one pair. So the first month is one pair. Remember, it takes them a whole month to mature. So you still have one pair in February. But in March, they finally got a baby because it took a whole month from February to March. So you have the original family parents and then the new babies. So you have two pairs. And from that moment on, as soon as they are fertile, they are going to be getting babies every month. So that means that the original parents for April have a new pair of babies. And now the first pair of babies, now they're mature. So now for the next months, they can have babies. So in April, they have 3 pairs of rabbits. And then by May, the original parents have a third pair of babies. The first pair of babies have their first babies. And now their second pair of babies are mature enough to have babies. So you got 1, 2, 3, 4, 5 pair of rabbits. So you can ask the student to maybe do 1 or 2 more. But after that, it's going to be too hard to just draw it. But it could be a starting point, right? So you could do the starting point with that pair of rabbits. And what would I also use besides drawing it? I will also do a table, right? So the Fibonacci is actually a sequence. It's not just called Fibonacci Rabbits. That's the activity name that is called Fibonacci Rabbits. But the activity, the sequence is called Fibonacci sequence, okay? So if you look in here, I would continue doing. We had all the way to 5. And then I start observing what happens, 0, 1, 1, 2, 3, 5. It doesn't tell me that much, right? But if you notice, how do I get 5? By adding 2 plus 3. How do I get 3? By adding 2 plus 1. How can I get 1? By adding 0 plus 1. This 1. So as you see in here, you add the 2 previous terms to get the next one. And it starts with 0 and 1. Make sure that you have, because this question is in your homework and also on your test. So you want to be able to make sure you write in your explanation that you start with 0 and 1. And then you add the 2 previous terms to get the next term. And then if you continue all the way to 12 months, there are 144 pair of rabbits by the end of the year. Okay? And I also, I think, asked you to write like the first 10 Fibonacci sequence numbers. So the Fibonacci sequence does start on 0, starts with 0 and 1. The reason that we cannot start with 0 here, because otherwise we don't have any parents, right? Many original parents. So that's why we kind of move it forward, and we started in 1 for the activity. But the Fibonacci sequence starts with 0. 0 and 1 are the first 2 terms. Okay?